Hello everyone. I hope you are being well. Um, in this lecture, we continue the convection diffusion equation for in one-dimensional equation. We mentioned in the previous lecture that using the central scheme for the one-dimensional convection diffusion equation gives physically realistic results for a Peclet number less than 2. For Peclet number less than 2 or equal or less than 2, the central scheme gives physically results uh, and in this condition. Therefore, when the Peclet number, as mentioned in one example, if Peclet number greater than 2, the result is non-physically. And therefore, if the Peclet number is greater than 2, if Peclet number greater than 2, it means that the convection term is more dominant than the diffusion term. The Peclet number definition is equal F divide D, and F means convection term and D means diffusion term. The Peclet number is a relation between F to D. So we introduce the upwind scheme or first order upwind scheme for Peclet greater than 2. Um, the upwind scheme uh, used for all Peclet number. For all Peclet number, we can use upwind scheme. Upwind scheme. Uh, in today's lecture, we will first analyze the previous example using the upwind scheme, and then we will introduce other scheme such as quick, hybrid, power law, and second order upwind scheme. New example. Example 2. Um, Solve the problem considered in example 5.1 using the upwind differencing scheme for for case I u equal zero point 0.1 meter per second. Case 2 u equal to 0.5 with coarse 5-point grid. We repeat the example 1 with upwind scheme for 5 grid point oil for 5 cells. 1, 2, 3, 1, 2, 3, 4, 5 cells. Solution. The grid shown in Fig 3 is again used here for the discretization. This is discretization of this example. Um, okay, for internal grid or cell, 1, 2, 3, 4, 5 cells. 2, 3, 5, 2, 3, 4 is internal cells, and cell 1 and cell 5 is bounded or boundary cells. That left face and right face of the cells is boundary condition. Okay. At the boundary condition or at boundary condition node or cell, the use of upwind difference for the convection term give. In this, if the direction of flow is left to right or u greater than 0, therefore in this phase, f e phi e no, example fw phi w equal uh, fb phi b boundary condition. If in this this boundary condition is a and this boundary is b, therefore for cell 1, FW phi W is FA phi A. Okay. And at the node 5, at the node 5 in for node or cell, for node or cell 1, for node 5, for node 5, in this phase, FE phi E equal for upwind scheme, this is up center. Phi E equal phi P. Therefore, FB phi P. If for node 5 equal FB BP. Okay, minus FW phi W and right diffusion term. Uh, Therefore, for node 1, AW equal 0, AE equal D, and SAP equal, and SAU equal. For node or cell 2, 3, 4, this is coefficient of algebraic equation. And for node 5, this coefficient is for general algebraic equation AAP. Oh, AAP plus AE phi E plus SAU. Okay. For 5 node, we have 5 equation and 5 unknown. Um, phi, phi 1, 3, phi 4, and phi 5 is 5 unknown with solve the linear system of equation, we can achieve these unknown results. For case one, in case one, u is point 1 and f equal rho u equal point 1 equal gamma divided delta x equal point 5. Therefore, Peclet is point 2 and less than 2. Uh, in this case, the coefficient for 1 to 5, the result, finite volume solution, this is analytical solution, difference, and percentage error. All error is less than 2. Error less than 2%. Okay, this is a comparison between analytical and exact solution and numerical solution with using upwind scheme. The error is less than 2%. In case 2, u equal 2.5, f equal 2.5, d no change because delta x and gamma is constant. Therefore, Peclet number is 5 and Peclet number greater than 2 equal Peclet number equal 5. With using central scheme for this case, the result is unphysically. For this case, for node 1 to 5, this is finite volume results. This is analytical result, and this is percentage error. The error is 22% and is large error. Numerical results, analytical results, exact solution, and numerical results. The percentage error is large, but the trend of numerical solution or result same the exact solution, and there is no unphysically results. In this case, numerical results have large error that we can reduce these percentage error with increasing the number of cells in the tree case. Okay. For exact, this is result of another example that results similar step step result. So, okay, this is exact solution, exact solution. This result is for upwind 10 product 10 cells with increasing the cell number, the numerical results trend near the exact solution with 50 or 100. This means in upwind scheme by increasing and the cell number, the percentage error decreasing and decrease. Okay. Uh, this this is due to the first order accuracy of first order or upwind scheme. False diffusion in the first order upwind scheme. The false diffusion in the first order upwind scheme. When we use the first order upwind scheme for convection dominance problem, the method is usually stable and bounded. Stable and bounded. That is its main advantage. The main advantage of first order upwind is stable and bounded. However, this stability comes with a price. The first order upwind scheme introduces an artificial smearing of the solution. This artificial smearing is called false diffusion or numerical diffusion. It is called false because it is not a real physical diffusion process. It appears only because of the discretization method. This is important note. The false diffusion is appears only because of the discretization method. Important. Physical meaning. Let us recall the physical convection diffusion equation. This is a convection, this term is convection, this term is diffusion, and this term is source term. Rho u phi represent convection, gamma gradient phi represent the physical diffusion. Now imagine that the true physical diffusion is zero if we emphasize that gamma equals zero. Then the transport should be pure convection. Okay? If gamma equals zero, we have only pure convection term. In the pure convection, the scalar quantity should simply move with the flow without being smeared by diffusion. So, if a numerical solution still show a spreading or a smoothing of the scalar profile when gamma equals zero, that spreading cannot be physical. It is caused by the numerical scheme itself. That is exactly what we call false diffusion. Okay? Please repeat this text again for yourself. Another um, false diffusion make gamma equals zero means we have pure convection term. Any effect of diffusion we will false diffusion. Okay? In if gamma not equal to zero or opposite zero. In this term, the diffusion term cause uh, heat diffused from hot to hot air or around and generate a boundary or mixed layer that 100 to 0 temperature. If gamma equals 0, uh, this means no uh, diffusion term, and we um, therefore no boundary layer for these two hot and cold flow. This is true, and the temperature curve is a step shape. In in the case that gamma equals 0, any effect of diffusion will be false diffusion. This is the best way to introduce the concept of false diffusion. In the left side, for gamma opposite 0, there is real physical diffusion, so the sharp interface between hot and cold fluid becomes smeared naturally. In the right side picture in previous slide, gamma equals 0, there should be no physical smearing at all. The temperature jump should remain sharp and should simply be transported by the flow. So the ideal profile is a sharp step. If the numerical method predicts a smooth transition, even in this case, then that smearing is purely numerically. Why first order upwind produced false diffusion? In the first order upwind scheme, the phase from the upstream node. For example, in 1D positive flow, in this flow, 1D positive flow, for if the flow is horizontal and the grid is horizontal, okay, and the flow is right to left, left to right. In the scheme, in the discretization term, we have for these cells and for these cells, in pure convection term, we have FE VAE minus FW PW equal 0. Okay. For P, W, and E. Okay. Or in this point, no different. FAE in the PAE, PAE equal phi P, P capital P. FAE phi capital P minus FW phi W equal phi W equals 0. If we use continuity equation, Fe minus Fw equals 0. Therefore, Fe equal Fw. In these two equations results phi p equal phi w. This means that if f phi p equal phi w, this means the amount of phi p or amount of main cell is equal the upwind cell or the previous cells. Therefore, temperature discontinuity is preserved. Okay. Mhm. Suppose the exact solution is a sudden jump in temperature. Upper extreme equal 100, lower is 0. In this case, all upper cells is equal same. This is 100, 100, 100, 1. And this is 0, 0, 0, 0. And the result is physical results and the step temperature distribution achieved. For the case that the flow at 45-degree direction related to cells. The flow direction is 45-degree relative to side of face, of cells, or grid. In this case, if we use finite volume upwind scheme F for one cells Fe Phe minus Fw Pw equal 0. Okay. This is in this term the results is not pure one-dimensional. This in this case we must discrete the Gaussian equation is two-dimensional equation. Two-dimensional. Okay. Therefore, Fe Pha minus Fw Pw plus Fe excuse me, Fn Pn minus Fs Vs equal 0 for special cells, for example, in these cells. Or in suppose this is central cells. Okay, this is central cells. This is central cells. This is central this cells, and this is central this. Okay. FAFVA for upwind scheme, this is U, this is direction. FAE, PAE, PAE in this phrase, PAE equal Phi P minus FW, FW, Phi W. In this phrase, up in upwind scheme is Phi capital W plus Fn in upper surface. Fn Fn in this direction equal Fn phi p upwind. Upwind in this phase is phi p minus Fs Phi 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 in upwind is phi capital S equal 0. In this case, if we suppose or we use continuity equation, if E minus Fw plus Fn minus Fs equals 0. Uh, for special case, we suppose that Fe equal Fw equal Fn equal Fs. Therefore, in these two equation, we omitted the F 2 phi p equal Pw plus Ps or phi p equal Pw plus Vs divided by 2. Okay, this is important result that results false diffusion. Phi p equal phi w plus phi s divided 2. In this case, if hot temperature is 100 and cold temperature is 0, therefore temperature in all phi p if we use Tp. Tp equal 100 plus 0 divide 2 equal 50. This means that is a false diffusion that cause temperature diffuse from hot domain to cold domain. False diffusion is more serious when the flow direction is not aligned. This is a key teaching point. If the flow direction is diagonal or oblique to the mesh, then the first order upwind method became much more diffuse because the scheme transport information cell by cell along coordinate direction, not exactly along the true streamline direction. As a result, a sharp front moving diagonally mesh became smeared. This is one of the classic explanation of false diffusion in CFD. Also, false diffusion is usually introduced physically. We can also the first option terms. This truncation error term contains second derivative like a second derivative is the mathematical form. So it in effect the scheme add an x plus gamma phi. How to reduce false diffusion? 1. Refine the mesh. A fine grid reduces the numerical smearing because transport front is resolved by more cells. Align the grid with the flow. If possible, in the actually it is not possible. We use unstructured grid that not align the grid with the flow. This is um, um, maybe used in the actual grid generation. These in 2 and 3 use high order convection scheme. We can use these two for reduction or false diffusion. One, refine the grid or refine the mesh. Therefore, we must analyze the independency of grid and use high order convection scheme such as second order upwind, quick, Pawello, TVD, high resolution bounded scheme for reducing or reduce the false diffusion. Um, for coarse grid, the false diffusion is large, and in this domain diffusion occur and error is big. With increasing the grid number and the accuracy or use the second order upwind, the accuracy increasing and the false diffusion decrease in CFD. Okay. Mm, with increasing this cell number or node number, the accuracy is increased because the false diffusion decreasing. Okay, another scheme is hybrid differencing scheme in the another lecture. Thank you. Goodbye.